I'm going to be talking about research that I've been doing on MDMA and other substances. I entitled it Beyond Fear because when I got first involved in this work in the late 90s, there was a whole lot of concern about whether people should even be giving MDMA to other people. And at this point now, there's a very long track record of safe administration of MDMA, and we've learned a lot, but there's still a lot more to learn. One of the key ways that people in science and the literature have been understanding MDMA is by thinking about it as something that reduces fear. But I'm going to argue that that's not really an adequate way to think about it, and that it's actually doing something else that's different, and I think more hard to pin down, but it's important to try and pin it down. So, as you just heard, I worked on the first federally funded MDMA administration study in the US in '98. Afterwards, I worked with MAPS to help them get permission to give MDMA to patients, and I've studied a bunch of different drugs. The work that I'm going to show you is work that has been done at a number of places. I'm finishing a postdoc at University of Chicago right now, where I work with Harriet DeWitt and fellow postdocs Matthew Kirkpatrick and Megan Wardle. The bulk of the work that I'm going to show you was collected at California Pacific Medical Center, where I've had the good fortune to work with John Mendelsohn, Gant Galloway, Jeremy Coyle, and Kat Garrison. And I kind of started my human research career at UCSF with Rhys Jones. And there'll be a couple bits of data that I'm going to show you that are from our colleagues at University of Basel, where there's a lot of really wonderful work going on right now. So LSD was discovered many years ago, and we're kind of at an event that is in some way is corresponding with the anniversary of Bicycle Day. We're a little off at this point, but pop quiz, where was LSD discovered? That's right, Basel. So it was discovered in Basel by Albert Hofmann, of course. So here's my next question, why Basel? Well, obviously Sandoz was there, but why was Sandoz there? Basically, the answer is that many of the modern pharmaceutical companies started as dye companies. And so back in 1856, Perkin discovered morphine, which is the first synthetic dye, and shortly thereafter, lots of different companies were formed in order to create these dyes for which there's a huge demand. And it's the nature of the industry that if you're trying to dye fabric or work with these sorts of things, that you want to be on a source of water, which is basically why Sandoz is in Basel. And as people worked with dye, they rapidly realized that a lot of these dyes would not just bind to cloth, but also to biological organisms and tissue, and that you could often see different things with the dyes. And it led to this idea that maybe these dyes would have biological effects. In fact, the person who came up with the idea of chemotherapy, Paul Ehrlich, talked about magic bullets, which was actually inspired by German folklore, this idea you could get a bullet that would hit any target you wanted. And so people started using dyes as medicine, and so some of the first modern dyes, or first modern drugs that we have, including the first antibiotic, was actually a dye. And the reason I'm introducing this history is I want to kind of raise the question of, actually let me say one more thing first, which is another interesting point about this is that patent law at the time protected the process, but not the resulting chemical. And so this gives rise to two things that are important to us. One is that drug companies use trade names. So instead of calling it diacetylmorphine, you call it heroin, because even though some other company might sell the same compound, the consumer will associate this trade name with your compound and won't buy the competing ones. Another important thing that comes out of this is that companies would try to patent many different processes in order to protect themselves from competition. And so what we see here is the patent for MDMA, which was patented in 1912 for basically this purpose, just as a protective thing, so that not for any real indication, they didn't know what they had in their hands, but just because if they owned the patent to this manufacturing method, then other people could manufacture things with the same method. So MDMA is in some ways a descendant of a dye, at least in terms of the company that first worked on it. And so I want to raise the question as I give this talk about whether it might be productive for us to think about drugs like MDMA as functioning in some way like a dye. maybe they make things more easy to see that are otherwise difficult to see. So I'm going to be showing you a bunch of research that I've been working on with my colleagues. And the basic overview is that I'm going to argue that MDMA really is doing something novel. It's not a typical stimulant. And the reason that the easiest way that you can show that is by showing that it has kind of drunken, sedated kind of effects. Whereas if you give higher doses of, say, methamphetamine, people feel increasingly alert. If you give higher doses of MDMA, people feel kind of stoned. But it's also not a typical hallucinogen. And the easiest way to argue that is that the effects on mood are much too consistently positive. If you give something like psilocybin, you get fluctuating mood effects, and it's variable between people. If you give MDMA, it's much more consistent effects. I'm going to talk a little bit about the work that we and others have been doing on how it works. We'll first look at sort of the neurochemistry, and I'll try to make the case that serotonin and oxytocin are really important to the effects, but that it's not something where there's just going to be like a one-sentence explanation. And I'm going to show you some data on norepinephrine in order to demonstrate that. And then I'm going to talk about the psychological effects, where we've been trying to look at how it might be pro-social and how it affects something that I am calling authenticity. And as I said, I'm going to argue that it's not really about reduced anxiety. That's not a core effect, and it may be something more similar to authenticity. At the bottom, there's a note to myself to remember to say that I'm going to be showing you research where we give MDMA to healthy volunteers, and it's the nature of the research that we're really only looking at short-term effects. So we're not looking at patients. We're not able to look at whether people are improved by being in these studies. It's really what happens in, say, like 0 to 8 hours after we give it. In some studies, 0 to 48 hours. So the study design would be that people come into a lab on multiple occasions. On one, they get placebo, no drug, and on another, they get MDMA. We don't know which day is which. And we do measures exactly the same on the 2 days so we can compare them. The way that we measure drug effects is something where, at the most basic way, we do something that's like ridiculously stupid, but yet it works, which is we give people either a computer screen or a piece of paper. Here's a replica of a piece of paper. And we ask them to rate different possible things they might be feeling by making a mark on a line, where on one side you have not at all, and on the other side you have extremely, or most ever, or something like that. And they just make these marks to indicate visually how much they're feeling this way. And then we measure them. And so we turn this sort of visual indicator into basically a percent number. And having done this, we can make graphs where we look at the averages of these numbers and how they change over time, because this is a fast way to ask a bunch of questions. And so here's one result of doing that kind of questionnaire that makes me say that MDMA is not a typical stimulant. And so sort of on the bottom, on the horizontal axis, we have times, and 0 is before we give the MDMA, in our sort of schematic way of looking at it. And then we make measurements, possibly once every hour. And the white line is placebo. The red line is MDMA. And those things that look like eyes are error bars. And it indicates that while we think the average is right in the middle of that eye, it's possible that the real number, the real average, is somewhere around there because there's some variability in our estimate. But what you can see is that on the far left, and vertically we just have that number, the average of that number from measuring that line. And we'll typically do a change from pre, so it'll start at 0 and then it can go either up or down. And so what you can see here is that on the left we have clear-headed, and people are feeling less clear-headed on MDMA. In the middle we have confused, people are feeling more confused on MDMA. And on the far right we have drunken, where people are feeling a little drunken. And this is all stuff that more or less resolves after a few hours. Not what you expect with a stimulant. Similarly, we can look at kind of typical hallucinogen effects. And you do see some typical hallucinogen effects, but you really see some other stuff too that makes you think that, or makes me think at least, that this is not a typical hallucinogen. So like positive mood effects. And this isn't the best demonstration of that. Actually it is. No, it's a good one. So here I've got closeness to others on the far left, feeling of kindness in the middle, and feeling loving on the right. And so you can see that we have really robust changes here in our volunteers. And this isn't something that you would reliably get with LSD or psilocybin. You know, sometimes maybe, but not in everyone or close to everyone. So in terms of how this works neurochemically, what we can say is that MDMA is complicated, but serotonin does seem to be important. So specifically the serotonin transporter. And we can look at this by giving a drug before MDMA to try and decrease its ability to access the serotonin transporter. And this also decreases its ability to release serotonin. So here's a plot of people's feelings of closeness to others from when they're given placebo. So you get a flat white line. There's really no change across the 6 or so hours. And if you give them MDMA, they start to feel more emotional closeness to others. If you give a drug that blocks MDMA's ability to access the serotonin transporter, you really flatten this out. So in that kind of pinkish color, we see that flattening. And if you give that blocking drug on its own, you see no real effect in that dark blue color. So serotonin is important. The serotonin seems to be important partly because it causes oxytocin to be released. And this is a peptide that's been in the sort of scientific news a whole lot in terms of its importance in bonding emotional attachment between mammals. Sue Carter, who's one of the world's experts on it, has described it as oxytocin being something that enables stillness without fear, which I think is a beautiful description. And so we've given MDMA and then we've measured oxytocin in the blood, which is not as good as knowing what it's doing in the brain, and they may be different, but it's the best you can do in a person. And if you look at the left plot, again, you see placebo in white at the bottom, and there's no change, and MDMA is showing us an increase at 2 and 3 hours afterwards. This is consistent with MDMA causing oxytocin to be released and oxytocin somehow facilitating bonding. And we've tried to address this a little further with a statistical analysis called mediation. And this is sort of an ugly, complicated slide, but the basic idea is that you might try to statistically ask the question of, if you have people feeling more social emotions on MDMA, does knowing the oxytocin level in their blood tell you more about their emotional experience than just knowing that you gave them MDMA? And if the answer is yes, as it is here, then that makes you think that the oxytocin is partly causing the effect. So I've been showing you these kinds of plots of either emotional effects or self-report effects or oxytocin. We can also, of course, measure the drug itself. And so these are the blood levels from 2 different studies, one where we gave MDMA and we plot the levels in red, and another where we give MDA and I plot those in green. And you can see that even though we gave the same dose of those 2 drugs in terms of amount of molecules of the drug per kilogram body weight, the MDA has slightly higher levels in the blood, and it seems to last a little longer. So we can take this kind of plot, and we can take the earlier plots of self-report data and try and put them together as a way to really visualize the relationship between the drug in the blood, which we assume correlates with the brain, and the experience people get. And if you do that, you can see that there's a lot of short-term tolerance that develops to the drug. So I'm going to show you data from MDA first. Along the bottom, we have the plasma level, and along the top axis, we have feelings of drug effects. And so you can take the first data point, which is going to be at 0, 0, where there's no drug in their blood and they aren't feeling any drug effects. And then you can plot 1 hour later. What you get would be something like this, where you have a line rising up. And then if you plot it at 2 hours, it doesn't just continue to go in the same direction, but it starts to go like this. And if you continue, you basically have the person coming down, and they're coming down faster than the drug effects are falling, and so you get this sort of shape. And you can look at a vertical slice in it, and what's interesting about this is that the 2 points in this shape are points where their blood levels of the drug are the same, but one is a few hours later, and the person is feeling much less effects. So this shows you that something has happened in the brain where it's become acclimated to the drug being there, or it's somehow adapted to the presence, or maybe something has run out so that there's much less effect. And so when people are coming down from MDA, they still have quite high levels of the drug. They're just somehow coming down. if you didn't have this sort of adaptive tolerance, you would expect to see a plot like this, where it would just go straight up and straight back down with no difference in the going up versus the coming down. But that's not what you see. You see this tolerance. And we can compare MDA to MDMA, left and right. And what you can see is that if you look at between like 2 and 4 hours, there's very little drop in MDA on the left and a big drop in MDMA on the right. So there does seem to be something different in this process where MDA is lasting longer and the brain isn't really adjusting to it as much. I would argue that this is probably also indirect evidence that MDA is more psychedelic and MDMA has more of a novel effect. But I think that it would need more research to really show that, but I think that's a helpful way of looking at this thing. And we can take it a little further because we can try and look at different types of effects. So what I'm going to do here is show not just self-report effects like we saw before, but also a physical effect. I'm going to show you blood pressure. And we'll do the same sort of reducing of effects that I showed you earlier by trying to block the serotonin transporter. And we'll do that for a study that blocks the norepinephrine transporter, so try to reduce the ability of MDMA to alter norepinephrine, and then we'll see how much that changes MDMA's effects, and then we'll look at how blocking serotonin changes the effects. And this is a way to look at how much we have MDMA effects that depend on one versus the other. And so this is from University of Basel, and what you can see is that if you give a drug that reduces norepinephrine component in MDMA, you reduce the physical on the left, the blood pressure changes, much more than you reduce the self-report changes. But if you look at blocking serotonin, it's basically the opposite. And these are data from my group, although we're predicting MDMA blood levels because we didn't measure them. And so if you look at this difference here, on the top, like norepinephrine seems to be more important for physical effects, and serotonin seems to be more important for emotional or self-report effects. And so even though I think that there's a big story that serotonin and oxytocin are really key to MDMA's effects, it's going to be complicated and there's going to be a lot of neurotransmitters involved. All right, so in terms of how it works, I've been talking about neurochemistry, but I think in some ways what's more interesting is the psychological type mechanisms. And if you look through the literature, there's at least to me 4 themes that you often see. There's an improved mood that people talk about as helping people to change their cognitive models or other things. There's increased feelings of connection with others. There's reductions in fear, and there's something that some people talk about in terms of an entactogenic response. In terms of improved mood, yeah, there is an improved mood, and I'm going to speed up a little now because I'm running behind, but a lot of drugs improve mood. In terms of increased interpersonal connection, I've already showed you a plot where people feel closer to others and kind and loving, so yes, that's there too. You might want to wonder whether it's something where people are actually just feeling it, or if they would behave differently towards other people or see other people differently. And we've looked at perception of others using a task where we have faces that vary systematically in how trustworthy they look. So I can go from untrustworthy to more trustworthy. And we have people make ratings, and MDMA shifts the ratings upwards, so people look more trustworthy when you're on MDMA. And if we give the serotonin blocking drug, we can block that effect, and so now it looks as if we gave the serotonin drug on its own. In terms of a reduced fear response, I don't think that this is quite a clear picture at this point. There have been studies that have said that MDMA reduces anxiety, but other studies that don't find an effect, and several studies now have reported increased anxiety, and that's what we see as well. So on the left we have anxious, increased, and on the right we have relaxed, decreased, which is a little weird. So people feel more anxious and yet more loving. It's not necessarily a contradiction because there's a lot of literature on sort of attend and befriend response to threats, where although science is often focused on fight or flight, there's another natural tendency for mammals to seek safety and comfort with others. So one thing that you might predict is that people, even if they're more anxious, wouldn't be socially anxious. And that's in fact what we see. Here's anxiety in some people, and here's social anxiety. So MDMA makes them feel a little more anxious, and it's not a huge amount, but it is there, but also less social anxiety. So they're anxious, but they're not anxious about people. If you look across many different groups, or many being 3, there does look like this kind of anxiety, to the extent that you can predict it, is in people who haven't had MDMA much and who are not really having as many people around them monitoring them. So on the horizontal axis, we have how many times people have used before they were in the study. Vertically, we have their anxiety. And I have data from 3 groups, and I've plotted them each separately. And although this is not really even a trend statistically, it does look like the Chicago group, where people are often on their own when they're on the drug, is the group where you see the most anxiety, and it's in the people who've had it less. So this does seem like it would be something that would be responsive to the context. So the last thing I want to raise is this idea of touching within. And so I really struggled with this for a long time. Like, how scientifically can you measure feelings of deeper connection with yourself? And there is a construct, it turns out, called authenticity, which is the idea is operation of one's true self without impediment. And so we found an authenticity inventory and gave it to people on MDMA or on placebo. And the plot's a little different here. The left is placebo and the right is MDMA, and one line is the males, the lower line, or the broken line is the males, and the other line is the females. And what you see is an increase between placebo and MDMA. So people do feel more authentic on MDMA. So in conclusion, I've argued that it's not really about reduced anxiety. It's probably more close to something like authenticity. And I do feel like it's a subtle, difficult problem, but that MDMA, sort of like a dye, is helping us to see things that are difficult to see. And so perhaps you're seeing the anxiety, maybe, that's there, but it's not necessarily causing the anxiety. That's speculation. But I think in general, it can help us to think that we shouldn't mistake the color, we shouldn't mistake the things that are being dyed for the dye itself. And the difficult problem that science still has to struggle with, I think, is actually determining in the MDMA experience what's the dye and what's simply the things that are being stained and made more visible. But I think the ability to make things more visible is extremely valuable. So thank you. And my slides are online if you want them. And
Hey, Matt, that was great. Thanks.
Thank you.
Given the tolerance curves you're showing, what's your thinking about the effect of supplemental dose, the timing of that in relation to the tolerance, and whether or not it would really have much of an effect?
So is the question whether there might be a way to administer it to reduce the tolerance, or I mean, because
no, whether the how the tolerance affects whether or not the supplemental dose will have much effect according to what time it's given. That's what I'm thinking.
The tolerance formation seems to be time dependent and concentration dependent. And I don't know that there would be any way to use our knowledge of it to like time a supplemental dose any better. I think that probably what should guide that decision is whether it works and whether it's safe. And as you know, it's been done a lot now, so I would defer to judgment of clinicians on that.
Okay, thanks. Yeah, it seems to be safe, but it doesn't necessarily work all that much. It's my impression, but thanks.
Mm-hmm.
Hey, thank you. In reference to the anxiety that some people experienced, my first inclination was to wonder if that is just a physiological response to the norepinephrine releasing properties of MDMA.
It's possible, and that would be testable. I don't think, I've done some studies where we've tried to manipulate noradrenergic components with prazosin, which is an antagonist, but I don't think we directly measured anxiety in that study. So yeah, I think that that's a reasonable explanation. I do think it is scary to be in a drug study. So it's rational for people to be a little afraid, and we're not talking about terror. We're talking about
right.
enough that they would be willing to report it. There are occasional adverse events with MDMA where people actually do feel like genuine panic and real fear. It's rare, but it happens. But I do think that it's an indication that this is not an anxiolytic, and that's the main argument I would make. Like if you really were giving something that actually directly affected anxiety, you wouldn't expect this.
Right.
Whatever the mechanism.
Thanks.
Hey, Matt, thanks for your talk. Two quick questions. One is, can you maybe explain the pharmacological mechanism of action of why oxytocin levels are going up? Do you have any sense of if it's, because of something that serotonin's doing first, or if it's a direct action? Is anybody looking at this? And I'll save my second question for a moment.
Well, the conventional story is that it's a 5-HT1 receptor subtype that's stimulating the release, but there's been some work with Pindolol in humans, which I would have expected to reduce that. And they didn't seem to get really any reduction in the self-report MDMA effects, which either means that the dose was wrong, or the theory's wrong, or maybe they just really didn't measure that effect cleanly enough. So
Any other hypotheses?
you could hypothesize that the directionality is reversed and that people are feeling emotional through another mechanism, and that
then,
causes the oxytocin to go up.
That's a good idea. My other question is, can you say a little bit more about what this authenticity inventory is?
So let's see if I can go back to that. Basically, it's feeling, there we go. Yes, one more. Yeah, there we go. So it's this idea that you are being you without impediment. And the questionnaire that we gave has 4 sort of subscales to it. One is that you know more about yourself, and another one is that you're not distorting information that's relevant to you or like who you are, and you're able to act in the same way. And then finally, that you're interacting with others in a genuine way. And so those references down there kind of build up this whole theory of this as a construct. And I'm not certain that this is the final best way to describe the experience, but I do feel like it's valuable in that it's a positive thing being described. So it's not like we're removing fear, but we're, okay, so maybe we are removing fear, but then what exists? What's the name for the thing when you're not afraid? It shouldn't be a not something. It should have its own name. And in a slide I skipped, I have an image from The Onion, which is sort of a joke, but also there's a need for us to have labels for emotional experience. And if MDMA is uncovering something that's a genuine experience, I think we need to understand what it is, what its effects are, and we need words for it. I'm happy to talk with people like in the halls or whatever. Just grab me. Thank you.
Thanks, Matt.